Okay, so if you're really keen on your mathematics and you want to do a little bit of extension or some ways of thinking in mathematics that's a little bit challenging, and you're somewhere between the age maybe of about anywhere from 9 up to about 12, 13, these are great maths questions for you to do. Okay, you can see here that they're from the UKMT, UK Maths Trust in the UK, and this is a junior maths challenge paper from April 2015. I'm going to talk you through the first 10 questions, but the best thing to do is have a go at these yourself to start with. Okay, so what I'm going to do is just leave you to have a go at these yourself to start with. It's best to pause the video now, and just have a go at these yourself, please. Thank you. So you should have had a go at these already. Don't just watch me do them, because you don't learn that way very much. We don't learn very much that way, I should say. But here we will go through now some solutions to these questions and have a look. Multiple choice, so you have to pick A, B, C, D, or E as your answer. So let's have a look. Which of the following calculations gives the largest answer? I think we just have to, in this case, maybe no shortcuts I can think of immediately, so we'll just go through and work them out. Or maybe some shortcuts. No, look. Oh yes, look. They've all got 1, 2, 3, and 4 in them. All of them have 1, 2, 3, and 4 of them. But these two, D and E, 2 of the numbers in that list are negative. And we're looking for the largest answer. So there's no way it can be D, because you've got 2 negatives in there and 2 negatives in E as well. These have only 1 negative in them, don't they? They only have 1 negative in them. But can you see this is -2, this one has -3, and this one has -4. So I think the largest answer will have the smallest of the negatives. So I think in this case, our answer would be A. So if you did spend your time working out the answer to all of these, have a look at that again, because there's actually a quick way of doing it by looking at negatives and positives and realizing the largest answer would have the smallest negative in the list, because the digits are all the same, 1, 2, 3, and 4. Okay, so that's quite cool. Right, number 2. It has just turned 22:22. How many minutes are there until midnight? A few different ways of thinking about this, I suppose, but there's 60 minutes in an hour, isn't there? 60 minutes in an hour. So this is 22 minutes past 10 o'clock. 60 minutes in an hour, so there's 38 minutes until 11 o'clock, and another 60 minutes after that. So 38 minutes plus 60 minutes is going to be 98 minutes. That's the answer there. 38 minutes till 11 o'clock and then 1 more hour, so 60 more minutes. So always count to the nearest hours. I suppose you could have done counting back 120 minutes from 10 o'clock to midnight. 120 minutes take away 22. There's a different way of thinking about it. Number 3, what is the value of this? Oh, wow. Well, let's have a look. 1 plus 2 plus 3 plus 4 plus 5, 9, 10, 11, 12, 13, that's 15. That's 15. So 1, 2, 3, 4, 5 divided by 15. Let's have a think about that. Now, look at the options we've got, and we can eliminate some straight away. This is a number in the tens of thousands divided by a number that's just 15. So 1, 2, 3, 4, 5 divided by just a number that's 15. So something in the tens of thousands divided by something in the tens, that's not going to be 1. It's not going to be just in the tens. Tens of thousands divided by tens is going to be something near the thousands. It won't be that one either. So it's going to be one of these two. It's going to be one of these two. Okay, and if you think about it, multiples of 15 will always end in a 5, so that doesn't actually help us at all. So let's have a think about, is there another quick way of doing it? I'm thinking it probably is D, but maybe there's not another quick way of doing it. Should we just do the working? And then I bet you someone can work out a much quicker way of doing this. 1, 2, 3, 4, 5. I bet there's some way you could do it. 15's into 123. How many would that be? Ooh, that'd be 6, 9, 7, 8. Oh, 8 15s. 8 15s are 80, 5 8s are 40, aren't they? So 8 15s are 120. And as soon as I know it's 8 15s are 120, I know then D is my answer, because it can't be 678. It must be this one. So I don't have to do the full working. And again, if you did the full working, as soon as you know that's 800 there, D is your answer. Number 4. Let's have a look. If in this partly completed pyramid, each rectangle is to be filled with the sum of the two numbers in the rectangles immediately below it. What numbers could replace X? What numbers could replace X? So we could just go through and work it out, I suppose. 105 take away 47, so that's got to be 58 there, because 58 plus 47 is 105. That would have to be 27. Then 27 plus 20 would be 47. 13 plus something is 20, that would be 7. So we need X plus something giving us 7. Oh, but 9 plus something has to be 13, so that's got to be 4. So I think it's 4 plus X has to be 7. That's going to have to be the number 3. If we work logically through there, you can see that's got to be the number 3. Okay, I don't have to find the rest of it because I only need to find what X would have been. The difference between 1/3 of a certain number and 1/4 of the same number is 3. What is the number? Okay, so 1/3 of the number and 1/4 of the number. So 1/3 of X, whoops a daisy. Let's just get my writing back on. 1/3 of X, 1/3, 1/3 of a number, 1/3 of the number X, subtract 1/4 of the number X, has to be the number 3. So if you know algebra, you can set up an equation like that. We can multiply the whole thing by 12, and you'll get 4x minus 3x equals 36. So x would be 36. Just thinking, is there a better way of doing it rather than just thinking of, oh, that's the wrong one. We'll see 36. Is that without doing algebra? Well, 1/4 take away 1/3. Oh yeah, you could just do it without using algebra. You don't need algebra, do you? You could just do, well, 1/4 take away 1/3. That's, sorry, other way around, isn't it? It's 1/3 take away 1/4. The difference, the bigger part of the 1/3. So 1/3 take away 1/4 is 4/12 minus 3/12, which is 1/12. So 1/12 has to be 3. 1/12 has to be 3. In other words, the whole amount would be 36. That's the slightly quicker way of doing it that way, maybe. What's the value of X in this triangle? Let's have a look. What's the value of X in this triangle? Let's have a look. What angle's on a straight line? So that would be 70 degrees there, wouldn't it? Angles on a straight line. That would be 60 degrees there. 70 plus 60 is 130, so X is going to be 50. Let's have a look at the next one. The rest of the calculation, 1, 2, 3, 4, 5, 6, 8 is mostly the same as 9, 8, 7, 6, 5, 4, 3, 2, 1, except that 2 of the digits are in a different order. What is the sum of these 2 digits? So let's think about that. Well, if I was doing 1, 2, oh dear. Now you don't have to do the whole calculation again, but 1, 2, 3, 4, 5, 6, 7, 8, 9 times 8. We haven't got to worry about the rest of it because 9 times 8 is, of course, 72. So we know that, look, it must be the last 2 digits that are in the different order. It must be, because this calculation would end with a 2. So it must be the final 2 digits that are around the other way in a different order. And so if those 2 digits are the ones that are around the other way, the sum of those digits would be 3. Okay, number 8. Which of the following has the same remainder when it's divided by 2 as when it is when it's divided by 3? Well, it's not A, because 3 divided by 3 has no remainder. 5 divided by 3 has a remainder of 2, but a remainder of 1 when divided by 2. 7 divided by 3 is a remainder of 1 when divided by 2. Yes, it's that one. Just check the other ones. That's got no remainder when it's divided by 3, and that's got a remainder of 2 and a remainder of 1, respectively. So simply, it's 7. Yep, just to think about that one. They both have a remainder of 1 when divided by 3 and 2. That's right. Okay, according to a newspaper report by a 63-year-old man has rode around the world without leaving his living room. He clocked up 25,048 miles on a rowing machine that he received for his 50th birthday. Roughly how many miles per year has he rowed? Well, we're doing a rough calculation. It's roughly. It's a real mathematical skill there. So it's roughly 25,000 divided by 50. Well, dividing by 10 will do that for you. 25 divided by 5, of course, is 5 and a couple of zeros. So 500, roughly. Good math skill, that, being able to just quickly do rough calculations. And lastly, number 10, in the expression 1, and then these kind of gaps in between the numbers are going to be replaced by a plus or a multiplication. What is the largest value of all the expressions that can be obtained this way? Ooh, what's the largest value that can be obtained? Well, I think a multiplication would be kind of, worthless here because it would be multiplying by 1, wouldn't it? So I think it's probably going to be multiplications are required elsewhere because that makes numbers usually bigger, quicker. But then let's not waste a multiplication there. What does that give us? Multiplications before addition, don't forget, BIDMAS, BODMAS, or BEDMAS, depending on where you're working from. And we get 2 times 3 is 6. 6 times 4 is 24. So this would be worth 24. This product here would be worth 24. And then 1 plus 24 would be 25. So you can achieve 25, which would be the biggest amount you could make. So that would be part E. Now, the rest of these questions, the rest of the paper, the next 15 questions, which do get progressively harder, can be found here at the link below. Whoops. They can be found here at the link below, right there. And there's actually solutions as well, but obviously you don't get videos talking you through the solutions. It's just solution papers. So hopefully you've enjoyed this and look for some more post-ups. And as I said, if you want to really improve your mathematics, this is the type of thing that will really, really boost your maths and boost your math skills.